Hi Year 11, I hope you're all well and having a lovely day. Today we're going to carry on our work that we started yesterday on surds. So here we have three surds we're going to simplify, and we're going to use that same rule we did yesterday. But today we're mostly going to look at going from this form into this form and then taking it on sort of one step further. Now, a lot of things in simplifying surds I think are quite similar in principle to simplifying fractions. And just like how with fractions we like to cancel them down, with surds we like to make the number inside the square root as small as possible. But the way I do this is to look for something that I can square root. So on each of these three numbers, I'm going to look for a factor of the number inside the square root that is square, so that I can square root that bit, making the number inside the square root smaller. So for example, can you think of any factors of 45 which are square? Yep, I can think of one. It's got a factor of 9. So using this rule, where AB is 45, I'm going to make this A 9. So I'm going to write it as the square root of 9, but I still need to multiply that up to make it to 45. I'd have to times it by the square root of 5. But now we know that the square root of 9 is 3. So really root 45 is the same as root 9 times root 5 is the same as 3 root 5. And we see that as simpler. We prefer to work with 3 root 5 than with root 45. So whenever I see a surd on its own like that, I always look for a square factor. Find the square factor and what you'd have to multiply it by, and then square root it. Maybe pause the video now and see if you can do the same thing for root 150. Can you find that square factor and then the other factor that goes with it, and then root it for the simplified version? Have a go. Okay, hopefully you've had a go at that now. If not, maybe if I do the first step for you, maybe pause it and see if you can do the second step on your own. So 150 has a factor of 25, so I can write it as root 25 times root 6. And then the square, or put that equals in there, the square root of 25 is 5, so it's the same as 5 root 6. Now, question C is just, well, it's almost exactly the same, but there are a few different ways you could go about question C, because there are 3 different square numbers that are all factors of 72. It has a factor of 4, and a factor of 9, and a factor of 36. Now again, this is a bit like cancelling down fractions, where sometimes you can cancel it down by different things. The easiest way to do it is to try and cancel it down by the biggest square factor that you can. So the easiest way to do this one is to start off with 36 as the biggest square factor of 72, and make it root 36 times root 2, which gives us 6 root 2. Now we could still do that with root 4, for example. So if I was to make it with root 4, then it would be root 4 times root 18, and root of 4 is 2, so it would then give us 2 root 18, and that does still equal root 72, but the problem is that root 18 still needs to be cancelled down further, and we're going to do some more of these after in the next section. But I'll just show you quickly now, just in case you do find yourself at this stage. If I've got 2 root 18, well, root 18 has got a factor of root 9, so I would have to make it 2 times root 9 times 9 to make the 18 gives me a 2, so root 2. And then I know that the root of 9 is 3, so it's 2 times 3, which is 6 root 2. So I still can do it by starting with that smaller square factor, but my life was much easier when I found the biggest one. So on all of these in question 8, which you're going to do now, make sure you find the biggest square factor as best you can. So have a go at question 8. Should take you about 25 minutes, okay? So spend 25 minutes of focused work. If you haven't finished all of question 8 with 25 minutes of focused work, then just see how much you can get done and then come back to the video. Make sure you mark your answers as you go. Okay, I hope you all had a lovely time on question 8, writing those questions and answers in your books nice and neatly. One more section of the video today, and we're going to have a look at these ones, which is sort of a combination of the work we've done today and yesterday. Now, question A is a bit like that second version I showed you for C. So we can cancel down root 28, but it's already been multiplied by 7. So really, the main thing I'm going to do for this is just park the 7 to one side and focus on the root 28. Okay, so I'm going to look at the root 28, try and think of a square number that's a factor of 28. Oh, 4, that's a square number and it's a factor of 28. Now I can't just completely abandon the 7. I'm just not going to work with it. So I'm still going to write my 7, because this just means 7 times root 28. So it's 7 times, and now I've put that 7 times there, I can just forget about it for the time being and concentrate on the root 28. Root 28 is root 4 times root 7, and then I'm going to bring my 7 times down again because it needs to be there, but I don't want to worry about it. Root 4 is 2, and then I can just bring my 7 in. Oh, sorry about the focus, hopefully it'll come back. Then I can bring my 7 in. 7 times 2 is 14, so it's just 14 root 7. Let's see if I can make this autofocus work. Question B says root 15 times root 40. So again, when I've got these two, actually I don't want them as two separate roots. It's going to be simpler to times them together to make them one square root. 15 times 40 is 600, because I know that 10 times 40 is 400. 5 times 40 is 200, so 15 times 40 is 600. So that just equals root 600. But then again, as soon as I've got one surd, I always look for a square factor, quite a nice one in root 600. I know it's got a factor of 100. So it's root 100 times root 6. And we know that the square root of 100 is 10. So it's going to be 10 root 6. Last one is slightly fancier, and actually this is something I could have done on part B. Sometimes you're better off, your life's going to be much easier if you can spot a surd that you can simplify more in the first place. Just draw a line down here so I can keep my work nice and separate. Okay, so in this one, root 52 I can already simplify. I can't simplify root 13, but I can simplify root 52. Now I could plough on and do 40 and then work out 52 times 13 and so on, but actually my life's going to be much easier if I do the root 52 first. So I'm going to leave my 10 root 13 here, leave my 4 here, and concentrate on my root 52, because 52 has a factor of 4, which is obviously square. So root 52 could be written as root 4 times root 13, and then we know that root of 4 is 2, so I've got 4 times 2, which is 8 times root 13, so I could simplify that to 8 root 13. And now all of a sudden my question has become much, much simpler, because instead of doing root 52 times root 13 and doing that whole mad sum, I've just got 8 times 10, which is 80, and root 13 times root 13, which is obviously just 13. And then I can just do 80 times 13, bit of grid method, 800, try not to mess it up, sir, 240, so it's just 1040. Who knew? 4 root 52 times 10 root 13 is actually just an integer. It's 1040. Have a go now at questions 9 and 10. Spend about 15 minutes on them. Hopefully that should be enough time for you to get most of them done. Make sure you mark as you go. Have a lovely day. Email me if there's any problems, and I look forward to speaking to you tomorrow.